This is the Math Module 1 practice test. I'm going to walk through all of the problems on this practice test. It is very similar to the real test, so if students know how to solve these, they should do really well on the actual test. The first question says, Jennifer has taken an online boating safety course and is now completing her end-of-course exam. As she answers each question, the progress bar at the bottom of the screen shows what portion of the test she has finished. She has just completed question 15, and the progress bar shows that she is 25% complete. How many total questions are on the test? Students are supposed to use a table, a diagram, or an equation to justify their answer. So a few different options they can do. For myself, I'm going to do a tape diagram for this one. I know that 25% is 1/4. And because I know 25% is 1/4, I'm going to set up a tape diagram with 4 sections. Jennifer has finished 1/4. She's finished 25%. And that 25% right there, that 1/4, was 15 questions long. And so if I know that a 15 is in this box of the tape diagram, I know that there's going to be a 15 in all of these boxes. So I'm going to go ahead and fill those in. Now that I know what goes in every box, I'm looking for the total number of questions on the test. So that'd be this 15 times the 4 boxes. We have 4 15s, so 15 times 4 is equal to 60, which tells me that there are a total of 60 questions on this test. Number 2, Lucy hopes to play beach volleyball in the Olympics someday. She has convinced her parents to allow her to set up a beach volleyball court in her backyard. A standard beach volleyball court is approximately 22 feet by 44 feet. She figures that she will need the sand to be 1 foot deep. So we have a length, we have a width, and we even have a depth for what she needs, the sand she needs. So Lucy goes to the hardware store to shop for sand. She sees 2 different options. She sees brand A and brand B. Brand A is 60 pounds for $3. Brand B is 150 pounds for $10. The question, letter A, is what is the rate that brand A is selling for? Well, I know it's 60 pounds for $3. So we could say the rate is 60 pounds for every $3. And then we are supposed to specify the unit rate. The unit rate is shrinking this down as much as you possibly can. So we're going to look to see how much one single dollar, how many pounds it will get you. So if it's 60 to 3, we know if we divide 60 by 3 and divide 3 by 3, that will give us the unit rate. So $3 divided by 3 would give us down that single dollar. 60 pounds divided by 3 would give us 20 pounds, LBS for pounds. So 20 pounds for every dollar. So I'm going to write this out. The unit rate is 20 pounds per dollar. The next question says, which brand is offering a better value? Explain your answer. Well, we already know that brand A is, nope, not $20, sorry, 20 pounds. 20 pounds for $1. We need to figure out brand B. So brand B, it's a 150-pound bag, and it costs $10. So 150 to 10. If I want to figure that out for a single dollar, how much it would get you, I'm going to divide both by 10. So 10 divided by 10 is $1. 150 pounds divided by 10 would be 15 pounds, or 15 pounds per dollar. So back to this letter B. Brand B is 15 pounds for $1. So the brand offering the better value is brand A, because you get more pounds of sand for every dollar you spend. So brand A is a better value at 20 pounds per dollar. All right, and then C. Students had a lot of questions about letter C. Lucy uses her cell phone to search how many pounds of sand is required to fill 1 cubic foot and finds the answer is 100 pounds. So for every cubic foot of sand that she's going to need, it's going to weigh 100 pounds. We're going to choose one of the brands above, A or B. I'm probably going to go A because it's a better deal. So we're going to choose one of the brands, and we'll figure out how much it's going to cost Lucy to purchase enough sands to fill the quart. So we remember from the front side of the paper that the quart is going to be 22 feet wide. It's going to be 44 feet long, and then she wants it to go down 1 foot. So it's going to be 1 foot deep. So 22 and 44, and then 1 foot deep. So we can use this volume formula, volume equals length times width times height, to figure out how many cubic feet of sand she'll need. So volume is equal to 22 times 44 times 1. We can just ignore this times 1, because anything times 1 is just itself. So its volume is equal to 22 times 44. 2 times 4 is 8. 2 times 4 is 8. Got our placeholder 0. 2 times 44, again, is 88. Add those together, she'll need 968 cubic feet of sand. But that's not really the question. The question is, how much will it cost for her to purchase enough sand? We know that she'll need 968 cubic feet, and we know that each cubic foot weighs 100 pounds. So the first thing I'm going to do is I'm going to figure out how much all the sand that she needs to fill up all of this, how much it's going to weigh. So it's 968 cubic feet times the 100 pounds that each cubic foot weighs. So the answer to that is 96800. So that's 96,800 pounds. And then we remember that the sand comes in the dollar ratio is 20 pounds for $1. So if I want to figure out how many dollars this is going to cost her, I would take this and divide it by the unit rate for brand A. So 96,800 divided by 20. Twenty goes into 96 4 times. That's 80. 16. Drop this 8. Okay. 20 can go into 168. 8 times. It's 160. Okay, 20 goes into 80 4 times evenly. That's 80. Drop down this side, 0. All right. So it will cost Lucy $4,840 to buy enough sand to make this volleyball court. Question number 3. Ben and Sven have different part-time jobs after school. They're both paid at a constant rate of dollars per hour. These tables below show how many hours they work and how many dollars they earn for each one. The top ratio table is for Ben, the bottom one is for Sven. So our job is to find the missing values in the two tables above. So we need to figure out these two boxes here, this one, and that one. So let's start with Ben. Ben will make $16 if he works 2 hours, $32 if he works 4 hours, $48 if he works 6 hours, and so on. So we see that if we travel across the top of this ratio table, it increases by 2 each time. And the bottom row, 16, 32, 48, that one increases by 16 each time. So if we want to figure out these two, we know that the bottom row every time increases by 16. So if we take this 96, and if we add 16 to it, it'd be $112 if you worked 14 hours. And then if we add another 16, it'd be $128 if you worked 16 hours. Now for Sven, his top row goes up by 3 each time, bottom row goes up by 30 each time. We could also look at how the top and bottom are related to each other. So the hours times 10 always equals the dollars, because 3 times 10 is 30, 6 times 10 would be 60, 9 times 10 would be 90. Let's jump over here. 21 times 10 would be $210. Okay, so we have found the missing values. We got that. Letter B. Who makes more per hour? Justify your answer. So if I look back at this table, Ben and Sven. Ben makes $16 for every 2 hours he works. $16 for 2 hours. Sven makes $30 for every 3 hours he works. So if I simplify these both down to get the unit rate, Ben would make $8, because that's 16 divided by 2, $8 per hour. Sven would make 30 divided by 3 is 10, so he makes $10 per hour. So who makes more? Well, Sven makes more per hour. Write how much Sven makes as a rate. What is the unit rate? Okay, so Sven's rate, you could say, and we already sort of figured this out up here. So Sven makes $30. The rate would be to 3 hours. And then the unit rate, if we simplify that down, both 30 and 3, they're both divisible by 3. So if we simplify this, we could say, well, he makes $10 for every 1 hour, or $10 per hour. How much money would Sven earn for working 16 hours? We know he makes $10 an hour, so if he worked $10 per hour times 16 hours, hours and hours cancel out, 10 times 16 is equal to $160. And letter E, what is the ratio between how much Ben makes per hour and how much Sven makes per hour? Well, Ben makes $8 an hour, Sven makes $10 an hour. So their ratio, Ben to Sven, would be 8 to 10. You could also simplify that down to an equivalent ratio of 4 to 5. Letter F. Sven works 1/10 of an hour per dollar. Write a 1 or 2 sentence explanation of what this rate means. Use this rate to find how long it takes for Sven to earn $230. So we say, so Sven makes $1 for working 1/10 of an hour. This means he makes $10 for working a full hour. Because it was 1/10 of an hour would make $1. And then if we multiply this times 10 and multiply the dollars times 10, 1/10 times 10 would be 1 hour. $1 times 10 would be $10. And then the second part of the question is, how long would it take for Sven to earn $230? Well, we know he makes $10 per hour, so we could take the $230, divide it by our $10 per hour, and that would tell us that it would take him 23 hours to make $230. Number 4. Your father takes you on a trip. Your father takes you to your cousin's house for dinner. He drives 60 minutes at a constant speed of 35 miles per hour. He reaches the highway, quickly speeds up, and drives another 30 minutes at a constant speed of 74 miles per hour. So your father is driving 2 different rates. For the first part of your trip, he's going 35 miles per hour. And he's doing that for 60 minutes, which is 1 hour. And then for the second part of the trip, he's going 74 miles per hour. And he's doing that for only 30 minutes. 30 minutes is the same as 1/2 of an hour. So we're trying to figure out how far you traveled. So the first one, you were going 60 minutes, which is 1 hour, at 35 miles per hour. So 35 miles per hour divided by the 1 hour, times the 1 hour. 35 miles per hour times the 1 hour is equal to 35 miles. And then the second part, 74 miles per hour times 1/2 of an hour is the same thing as saying 74 divided by 2. 74 divided by 2 is 37 miles. So these are the 2 parts of the trip at the 2 different speeds. You traveled 35 and then you traveled another 37. So if we add those 2 together, the total distance you traveled is 72 miles. And then we're supposed to figure out how long the trip took. Well, we know it took 60 minutes for the first part, and then 30 minutes for the second part. So 60 minutes plus the 30 minutes, a total of 90 minutes, or if you want to say that in hours, that'd be 1.5 hours. The final question says, your older brother drove to your cousin's house in a different car, but left from the same location at the same time. If he traveled at a constant speed of 60 miles per hour, explain why he would reach your grandparents' house first. You can use words, diagrams, or numbers to explain your reasoning. All right. The one on the actual test is simpler than this one on the practice test. The one on the actual test, you can easily show it with a double number line or with a tape diagram. For this one, the best way for us to show it is we've practiced using the distance equals rate times time formula. And for this one, we're actually we're trying to figure out how long it took the brother to get to the cousin's house. So we're trying to figure out the time. So if we switch this formula around, we find that distance is equal to time. No, I did that backwards. Ignore that part. Sorry, the rate cancels out. Time, which is what we're looking for, time is equal to distance divided by rate. So the distance they drove, we know that it's 72 miles to the cousin's house. For both the dad and for the brother, it's a 72-mile drive. So our distance is 72 miles. And the rate at which brother drove 60 miles per hour. So we have 72 miles divided by 60 miles per hour. The miles cancel out. 72 divided by 60. 60 can go into 72 one time. That's 60. 12. Drop down our 0. 60 goes into 120 two times. 2 times 60 is 120. That comes out even. So 1.2 hours for the brother. So we remember dad driving, it took 1.5 hours. Brother is driving, it took 1.2 hours. This is less time, therefore the brother would have gotten there sooner. So brother arrived sooner because it only took him 1.2 hours. Dad took 1.5 hours. All right, I hope this helps. Let me know if you have any questions, and you will do great on your test.